Hi again, this is Daniel Ritchie, the developer of Howler, and today I'd like to talk about Lua scripting. Lua is a language that is very easy to learn, fairly modern. It's used a lot in game engines and other types of applications. There is an implementation of Lua specifically for Dog Waffle Howler, and there are also implementations for other programs like GIMP and other image processing programs. So the scripts can sometimes be interchanged between different programs, and it's also a good learning tool. And interestingly enough, a lot of our filters were originally created in Lua and later converted into other languages. So let's start by pressing, let's see, K on the keyboard, or Shift K on the keyboard. No, K on the keyboard. There we go. Or we could go to View, and under Utilities, you can directly click on Lua Browser. But from the Plugins panel, we can go to Options and open Lua Browser. Either way, it will work. And as you know, under Plugins, we have a number of tools that expand and extend our functionality, and in fact, quite a bit of Howler is implemented as plugins. Well, the same goes for Lua scripting. Actually, a lot of our filters were originally written as Lua scripts. If you look under some of these tools, for example, Sunset Filter, you see we have this tool. This is actually integrated into the program now, but it originally started live in Lua, and we can see that if we browse, and I believe it's called Sunset as well, which would put it in the S's right about there. And as you can see, the programs are pretty similar looking. It has the same color swatches and a lot of similarities. And you can also see that the functionality is similar. Not quite as fast as our internal tools, but I mean, it's a interpreted language, or it's actually just-in-time compiled. So it is actually pretty fast. Not quite as fast as our native C implementations, but it's actually pretty respectable, given that it is just-in-time compiled. So let's look at the code here. Let's pick a good one, say this Ripple GUI, and click Edit, and actually look at what that code looks like. And let me actually run this Ripple GUI. There it is. You can see what it does. It creates sort of a ripple effect. And I will go back to the text, and let's look at how that was accomplished. This is the entirety of the script, as you see here. You can see it consists mainly of two parts. There's a GUI that's created, and then there's an event loop, and then there's the main function that handles the image processing, and that is up here. Let's first look at the main function called Wave. Functions in Lua are very similar to functions in other languages. They encapsulate functionality which can then be called from other parts of the program. Here are some variable declarations that just basically tells the programs what the names of the variables are you're going to use inside this function. There's some for next loops, or for loops you would call them. This is where they end. Inside that loop, there's a call to the progress bar that actually just sets this little green progress bar here called set RGB. That just basically puts the pixels on the screen. And this is basically here the core logic that actually does all the work. You can see there's this y divided by height times frequency is basically setting up how these waves are created, and there's a cosine using this y2 that we just created here as the main parameter. There's a constant value. Probably would have been better to have a little control in there to control that value too, but nonetheless, it's in there. Whoever wrote this decided to do it that way. There's updating some counters or something here. A little bit of logic that basically checks if the pixels go off screen. and basically clamps them if they don't, if they go off screen. And then there's finally this call that checks, gets the original pixel value using these displaced values. It then sets them to the screen, and we loop until all the pixels in the image are completed. And that's basically the entirety of this wave function. Now look down at the bottom of the program or the code script, and we see the main function loop. We start with call to save undo. Basically, if we want to cancel by clicking on the cancel button, this basically will allow us later to restore the original image even though we've made modifications to it. Here we see a call to set caption that basically sets a caption in the title bar called wave. Here we create a variable, it happens to be called h3, and it's filled with a return value from this function called add control. All these controls are created with this add control function. Here it's a text label, and the text that goes into it is called create a wave of a water effect, which you see right here. That's simply a text string that is shown on the GUI. Here's a blank text label, just an empty string. That just basically creates an empty space between that text label and the next control. Then we see a control called a scroller, and a second one also called a scroller. The first one receives a label called power. The second one receives a label called frequency, and then these are some of the basic parameters, like an initial value of 50, a minimum, and a maximum value. The final add control is another text label, which is empty. That gives us another space between that and the end of the interface. And finally, a call to open panel, which actually causes the program to open this panel. And then there's a event loop. This basically repeats indefinitely until somebody presses the cancel or OK button. There's one unique thing in Lua is that you can set multiple variables at the same time. You see IDX, retval, and retstring variables. This is an index, a return value, and a return string. They're all being set from this as return values from this one call called wait on event. This basically waits for something to happen from the user. For example, if the user clicked on one of these buttons, the event loop would receive the event and then continue processing. Otherwise, it sits there waiting for it to happen. Here you see variables called power and string and frequency and string, getting values from a function called get settings. This basically gets the actual settings. Say this scroller control had a value of 65. This would return that value. The second part, called string, is just sort of a dummy variable. Had this been a text label, it would have returned a string instead of a value. It can be safely thrown away if it returns a value instead of a string. All right. Here we see some logic that checks if IDX or index is -1, and if so, it goes ahead and processes this wave function, which performs the image processing function. And finally, there's a refresh of the screen, and it does some more logic. It tests if the index was less than 0. If so, then go ahead and repeat that indefinitely. Otherwise, close the panel, and then there's one final test that checks if the cancel button was pressed. If so, go ahead and restore the undo we called at the beginning of the program. This basically restores the original image, and that's basically how the cancel works. So that is, in a nutshell, an entire program that performs a useful function in just a little bit of script written in a text editor. You can then run it directly from the text editor if you like. When you cancel, you'll come back into the editor. So that is Lua scripting in Howler. Hope it's been informative. If you'd like to check it out, you can look at all our example scripts directly inside of the program. They are free for your use if you find it useful. You're able to modify that code and use it for your own purposes. Please let us know if you do anything interesting. That would be great. Thanks for watching, and ta-ta for now.